Assalamu alaikum. Hi guys, I welcome you back to my channel Radiology Fundamentals. I hope you are all fine and doing good. I am Enjeela Shafat and you are watching the third video lecture of my channel Radiology Fundamentals. If you are new to my channel, hit the red subscribe button and the bell icon to watch my next lecture of radiology learning. For any queries, questions or confusions, you can comment in a comment section or DM on my Instagram ID mentioned in the description of video. I am going to share the notes of the lectures too, so for that you can too DM me on my Instagram ID. Let's start our third lecture, which is photographic effect. So let's move towards the topic now, the process of photoelectric effect. I have made a diagram, very simple diagram here. You can observe it. This is an atom and it has got nucleus inside it, and around the nucleus are shell orbits. Okay, close to the nucleus is a K shell orbit and outside the K shell is L shell orbit. Alright, and inside these orbits there are electrons, negative charged electrons. Here I have made a photon which is outside the atom. This photon, when this photon comes in a very fast speed and accelerates, hits this electron, K shell electron, what happens? It completely removes this K shell electron from its orbit. You can see it here. It has just completely come out from its orbit. Now the question arises, how this photon removes this K shell electron from its orbit? It is because of the binding energy of photon, which is more than the binding energy of K shell electron, which takes out this electron completely from its orbit. Now what is binding energy? Binding energy is the energy which holds the nucleus together. So here comes that photon has got more binding energy than K shell electron. Alright. So this taking out of electron from its orbit with the help of photon is called ionization process. Now this electron, after coming out of K shell orbit, what happens? The space in the K shell remains vacant. Okay. Okay, now I forgot to say that when this electron comes out of the orbit, then this is named as photoelectron. Okay, after coming out of the orbit of K shell, this K shell electron is called photoelectron. Now back again, I said that the K shell orbit remains vacant because their electron has been removed. So it's necessary that this orbit should be filled with an electron. What happens? K shell electron from the L orbit comes out and moves towards the vacant space of K shell, and it gets to adjust there. Let me remind you that K shell electron has low energy because of the energy of proton and neutron inside the nucleus, the K shell electron gets its binding energy. Otherwise, it has got very, very low energy. So now what happens when L shell electron starts to get adjusted in K shell? It loses its few energy because L shell electron has more energy than K shell electron. And to let it adjust it in K shell, it has to lose its few energy. Alright. Now that remaining loosed energy of L shell electron is called X-rays. So here is the formation of X-ray. This whole process is called photoelectric effect. So from photoelectric effect, characteristic X-rays are formed. Okay, you have to make it a note here that from photoelectric effect, which kind of X-rays are formed? Characteristic X-rays are formed. Alright. Characteristic X-rays are discovered by Charles Glover Barkla in 1909. So we can define characteristic X-rays as X-rays formed or emitted when an electron is taken out from K-shell orbit completely. So let's move towards our next topic. First, let me show you the whole topic of photoelectric effect. It's like this. You can get the notes from Instagram ID. You can DM me there for the whole notes. Let's move towards our new topic, that is properties of X-rays. So the first property of X-ray goes like this. X-rays belong to the category of electromagnetic radiations, as I have already discussed it in my previous lectures. All electromagnetic waves have general form, means the characteristic electromagnetic waves have got general form that they travel with the same speed as light. And what is the speed of light? It is 3 into 10 power raised 8 meters per second. So it has got same speed as of light. Alright, this is the first property. The second property goes like this. X-rays are heterogeneous, having a short wavelength. It means that the X-ray beam, we can find photons with different energies. Alright, they have got different energies of photons with short wavelength. Now here's mentioned that the useful wavelength range in ordinary radiography is about 0.1 to 0.5 angstrom. Alright, angstrom is the unit of wavelength. 1 angstrom is equivalent to 10 power raised minus 10 meters, or we can say 0.1 nanometers. Make it a note. So this is also the important useful wavelength which we use in radiography is 0.1 to 0.5 angstroms. Okay. Now moving towards the third property of X-ray, that is X-rays are highly penetrating, invisible, means they can get absorbed, they can get through the solids, liquids also, and they are invisible. Like light, it is invisible. Same is the case with X-rays, we cannot see them, they are invisible. So moving towards the fourth property of X-ray, that says they liberate minute amount of heat on passing through matter. So whenever they pass through any material, any matter, what happens? They emit a kind of little bit of heat. Alright? This is the property of X-ray. And the fifth property says X-rays behave as waves and particles. Already mentioned in my previous lecture. Why they behave as waves as well as a particle? Because they are electromagnetic radiations, and electromagnetic radiations behave both as waves and particles, same as light. Now moving towards the sixth property of X-ray, which says X-rays leave the X-ray tube in straight line and line diverging from the focus, which means when an X-ray comes out of its origin, wherever it comes, whenever it comes out of its of the X-ray tube, it gets diverged, spread from the focus, it spreads out. Okay. Now the second property is they can cause fluorescence of certain crystals. Fluorescence means light. So they have the property of emitting a little bit of light. Eighth one is they produce chemicals and biological chains mainly by ionization and excitation. So they can produce chemicals plus biological chains, because whenever I can give you an example. If you are doing a kind of X-ray or any other like CT or MRI to a patient, and there is a chance sometimes what happens, the body reacts to those radiations. Okay, so there is a change in the body of a patient, we can say. So that is called a biological change, and it is due to the ionization and excitation. Ionization I have discussed, and excitation, what it means, it's same as ionization, but only the difference is that electron is not completely removed from the atom. It's only removed from the orbit and goes to the other orbit. Alright. So this was all about the properties of X-rays. I'll be discussing about interactions, 5 interactions of radiations with matter in my next lecture. For that, you can subscribe to my channel. Thank you for watching. Take care.